Alright, so we're going to cut this keyway here. And it's a 1/2 inch wide, so we're going to use a 3/8 end mill. So what we'll do is we'll go to manufacturer mode and set up, and we're on milling. I'll go ahead and change our stock to round. So I'm going to do a relative size stock cylinder and just put my stock at 0 because the shaft's already been done on a lathe, or it doesn't get cut down. Alright, so it looks something like this. And I don't know why Fusion does this. It's a round stock, but if you look, you can still subtly see part of the rectangular stock. I don't know why it does that. If I turn it completely sideways, you don't see it, but if you turn it at an angle, you can see that vertical line going down. Weird. It's like something in their computer code that even though when you put the stock as round, it still does the math based off a square stock, and it shows up in the simulation. Well, it's not the simulator, but in the preview, stock preview. Okay, so my axis is going to be the center of that. Okay, well, that already looked good. I didn't have to do that. Now notice my Z is pointing to the right, okay? So what I want to do is I want the Z pointing up. So I'm going to go to model orientation, Z and X. And the Z, what I'm going to do is I'm going to utilize this flat right here of the keyway. So I now have my Z pointing up. Now I want my X pointing to the left or right. So I need to turn my X, right? So I'm going to move my X. I'm going to base it off this line right here. So I now have it going in that direction. I'm going to go ahead and flip it. And we're going to say this part, the super spacer, we're going to say the chuck is on the right side of the mill table. So my X will be pointing to the right. And for my stock, I'm actually going to put it in the middle, okay? So usually on parts like this, your Y will be on the center. That's because the Y, the feature, the Y feature, or the feature is basically, it's symmetrical. Like if you were to put a line, a straight line going all the way across, this side would be mirrored to this side, right? So because of that, it makes it easier when making, if you have to edit any code or make any offset changes, it makes it easier if you put the Y0 in the center of the stock. All right. Now you can put it anywhere you want. I mean, there's no like golden rule to where your XYZ 0 should be. It's more what's more practical, like and that's based off how are you going to set your X and Y 0. You're going to use the edge finder. So it's all based off of what's the most usable functional place for it to be. All right, so I'm going to hit OK. All right, so this is pretty easy. But because the keyways, usually you have a tight tolerance. Usually you want to get spot on, so the key gets pressed in and stays in. You don't want to get too tight because you can get the key stuck in there. I've done that before. Or even worse, you go to fit the key in, and it gets like halfway in, and it won't go all the way in, which is rare. I mean, it's got to be pretty tight to do that. Or if it's too loose, it'll just fall out, right? It needs to be like it's got to fit in there, right? So because of that, I'm going to use two different types of tool paths. I'm going to use a 2D pocket, and I'm going to rough it out with a 2D pocket, but I'm going to save 10 thousandths for a finish per side and 2 thousandths for the floor. And then I'm going to do a 2D contour to finish it, okay? And with the 2D contour, the 2D contour will let you put a compensation, a tool compensation setting within the G code. 2D Pocket won't let you do that. 2D Pockets is just good for roughing. I mean, you can finish with the parts too, but the fact that it won't let you add a tool compensation into the 2D Pocket, I think it's kind of bull, really. Like, you should be able to do that, but you can't. That's because I guess they want you to use 2D Pocket for roughing and then come in and use 2D Contour to finish. When in all reality, a lot of times 2D Pocket will do the rough and finish. But anyways, so I'm going to go to 2D Pocket. I'm going to select my tool. I'm going to use a 3/8 end mill. It's a 1/2 inch keyway. You don't want to use a 1/2 inch tool. You can, but there's a good chance you're going to cut it oversized. Plus, you would have no control with compensation. I mean, you would, but basically, you could only go bigger. You couldn't go smaller, and you really don't want to do that. All right, so I'm going to go to my tools. And we'll add a 3/8 flat end mill. Notice one thing you should notice in Fusion. Notice anytime you make a new tool or new tool path, notice the numbers always revolve around 0.936. Okay, now it doesn't have to be 0.39. Like earlier, we saw 40 inches feed rate per minute or per revolution in one of the default feed rates for that tool we selected. 0.9 or just 3937. That's the magic number. The reason why you'll see that number in a lot of the Fusion default settings is if you take, let's see, calculator. All right, so for example, if you take 10 millimeter, all right, let's just do 1 millimeter. 1 millimeter divided by 25.4. Okay, so we're converting a millimeter to inches. All right, so look at the number, 0.03937, right? All right, so let's take 10 millimeter divided by 25.4, 0.3937, right? Say take 100 millimeter divided by 25.4, 3.937. So 1,039.37. So you see the pattern there? So because Fusion 360, you notice all their default settings always comes up around 3937. That's because their software is based off of metric, right? And I mean, I'm not a computer programmer. I don't know how they code their software, but it's all based off of metric settings. But anyways, that was just a little fun fact. All right, so we'll say we're cutting steel, because most time when you do keyways, at the school we mostly cut aluminum. I don't think you're ever going to see any aluminum keyways. I mean, I could be wrong, but aluminum key, well, it kind of defeats the purpose. If you think about the application of a key and keyway, it's for assembly purposes, and also it's a design fail point, right? So instead of welding the parts together and having the mechanical, the mechanism, if something was to get in a mechanical bind, you could, because you're usually working with like sprockets and gears, you could basically, you had sprockets and gears that are turned by a motor. You could either tear the motor up or the transmission, the gear set assembly. And those are really expensive. So, the key is basically just mild carbon steel, and it's a design shear point. So if something gets in a mechanical bind, the key is designed to give away before anything else, right? Now, if you're to make something out of aluminum, aluminum's softer than carbon steel, so a carbon steel key would be stronger than aluminum, and the key wouldn't be the shear point. At that point, the aluminum pocket for the key, or the keyway, that would be the shear point. So I don't think you're ever really going to see an aluminum keyway unless it's like some kind of special application. So most likely it's out of steel. So we're gonna do our speeds and fees based off of steel. Spindle speed, we'll go 3,000. And I always make the spindle and the ramp speed the same. Because if you don't, it gets kind of annoying, especially if you're like doing a pocket operation where you're doing a bunch of ramping. Because what will happen is the spindle will sit there, and you'll hear me, it'll jump pitches like back and forth. It'll just be like me. I sound like a mechanic trying to describe a motor right now, but you get the idea. It's gonna sit there and change pitches every time it speeds up or slows down, and it gets really annoying. So I wouldn't. I always put the spindle speed and the ramp speed the same. Okay. Where did my next tab go? There it is. Okay, so I'm gonna hit accept and select that tool. All right, so we're doing a 2D pocket. This is our geometry. I'm gonna lower these values to 100 thousandths. The bottom, so I'm gonna put it on selection, and I'm gonna select this floor right here. All right, passes. I'm gonna go multiple depths at 50 thousandths depth of cut, and stock to leave. I'm gonna leave 10 thousandths per side and 2 thousandths for the floor. All right, so let's go ahead and hit OK. Okay, so it's giving me a warning. The sum of the ramp clearance height and vertical lead-in radius is higher than the feed rate. Otherwise, the feed height will be raised to match the sum. Okay, so the math isn't adding up. And it'll change it for me. So here, we'll change that in a minute. It's going to automatically fix that for me. Okay, so here's my toolpath. So as you can see, it's just going to ramp in. So it's going to drop down right here, and it's going to gradually get lower and lower. Okay. Now, sometimes you want to get this closer to the part because it'll be just cutting air, and it makes your cycle time go up. If you're just running one part, no problem. But if you're running, like 100 of them, you want to speed it up as much as possible. Okay, so right here, the ramp clearance, it didn't like that number. All right, so I lowered it and they got rid of that error message. Okay, so that's that. And if you zoom in, you can see that I still have some stock. So, it's saving 10,000s right there, right? All right, so keyway rough. All right, so now we're going to do a finish pass. All right, so I'm going to go 2D contour. I'm going to use the same tool, same settings. Geometry, it's the keyway. The bottom height. All right, so the bottom, I'm going to put it on selection and select the floor. Passes, we're just going to take everything in one pass, so this is fine. Except right here, compensation type. I'm going to put that on where. All right. Lead in, let's just try these settings. Okay, so it didn't give me a toolpath, right? That means there's some kind of conflict. Yeah, the math ain't adding up. So, well, first, let's just click on this warning. Okay, it doesn't like the lead-in parameters. They could cause a collision. All right, so it's got no hints. All right, so let's do this. So let's look at the lead-in it's giving us. So I'm gonna go to the linking tab, and okay, so we'll give it an entry point. We'll say to start right here. And we'll try to reduce these numbers some. There it goes. Okay, so basically, what I did is you get to think about this. So we're using it. So it's a 1/2 inch keyway, right? Now we had saved 10,000ths per side. So let's take 1/2 inch, and we're saving 10,000ths per side. So that's two sides. So that's 20,000. So I'm gonna go minus 0.02. The tool we're using is 3/8. So I'm gonna go minus 0.375. Okay, so that's 105,000 difference, but that's overall. Now the side of the cutter that you're going to be using to cut, like as you engage into one side of the keyway, basically what you have to do is you have to take this number and divide by 2. So I'm going to divide this by 2. So we only have 52,000 clearance. So this was at, I think, 37,000. Now 37,000 is smaller than 52, but by the time you add in, you really have to add in this number plus this number. You had different. Let's see, there was something else too. We're going to be compensating also, so it's giving us 18 thousandths to work with on compensation. So basically, this parameter specifies a range of tool diameters that can be safely used instead of the only tool selected for its operation. The allowed range of tool radii start from the selected tool radius and goes up to the tool radius plus the given allowance. Basically, sometimes it puts a limit on, you can put a limit on how much you can compensate depending on the radius. You got to think you're working off the center of the tool. So even though it's a 1/2 inch radius, you're not actually cutting a 1/2 inch radius. You're actually moving the tool radially, at a radial move like GO2 or GO3 to cut the 1/2 inch. I said 1/2 inch radius, 1/4 inch radius, 1/2 inch wide keyway, so 1/4 inch radius. So because of that, basically, basically the math has to add up. I'd have to have an illustration or something to really show you how they're calculating the math on that. But this will work right here. So we got our 2D contour. And we want to make sure we're feeding in, but we're not touching the wall when we're feeding in or retracting. Okay. And we should be good there, but so let's go ahead and simulate that. Okay, so notice it's when it's done, the tool's at the center of the part, or the keyway for the most part. So I'm gonna rewind this. So when it comes out, notice it's coming off the key wall, right? That's the key. because you don't want to drag the tool up as you lift out of that pocket. I mean, it really wouldn't hurt nothing, but it would leave like a little subtle line where it does that. All right, so let's go ahead and post this code. So we added a cutter comp into the finish pass, right? Now you don't have to do it on the roughing. Sometimes it's helpful to be able to do that in the roughing, but Fusion won't let us do that in the roughing. All right, so I'm gonna put this on Haas. All right, so using a Haas mill, we'll use this Premium GC. I have good luck with that one. All right, so here's our rough keyway. It's a lot of code. That's because it's doing a bunch of little bitty moves. All right, little micro moves. All right, we'll go all the way to the bottom and find the finish right here. So we'll just call this finish. All right, so notice right here, it's got a G41 with a D9, right? So G41's cutter comp to the left, because we're going to be climb milling. And D9. This number usually by default matches up with the tool number. All right, it doesn't have to be that way. You could change these, but that's how we get that D9. So D9 is basically the cutter comp, number. Because you could have more than one cutter comp on one tool. So it's turning cutter comp on to the left using offset 9, and then it's going to run through the finish pass, which is all of this code, and then right here at the bottom it'll back up on the X and Y parameter. It'll be a linear move on X and Y, not Z, and it basically backs up. It backs up and cancels cutter comp. All right. Now you'll get an alarm if you have a Z move in here, or like if I put this G40 on like right here. Sometimes the machine will run it. I don't know why, but sometimes it won't. But a G40, a cutter comp cancel is supposed to be executed on a line of code that includes a linear move on the X and Y, or X or Y. Like if you just put a G40 by itself, it won't do it. Sometimes it will, but it's not supposed to. By the book, it doesn't really do it. Now, sometimes you don't have room to back up. Like you're just cutting something and you just need to basically cancel cutter comp. So a little cheat of what you could do is, what I'll do in that case, I'll I can't really give you a scenario as an example of where this would be useful, but there has been times where I needed to cancel cutter comp, but I didn't want to back up the tool or move the tool, because I don't remember what I was doing, but I didn't have I was having trouble with something. But you can cancel it without making a linear move by tricking the machine and making it think you're making a linear move, which, I mean, I guess you're not really tricking the machine, but what I've done before is I put a G40 and I would take this number right here that it's already went to and basically tell it to go there. Now, it's already at that position, so it's not going to really move, but it satisfies the machine's the code requirements to execute this G40 cutter comp cancel on a linear X and Y linear move. So it's you're telling it to go somewhere on the X. Now the thing is, it's already at that location. So that's just a little tip.